So hello everyone, this is a Sony TV 85-inch. I just picked it up from a customer place and bring it here to the shop to check it, because it wasn't like a easy problem, just like setup or power cord or something simple that I can fix in customer place. And the model number is a XPR 85X850F. If we plug the TV to the power, we don't have no standby light here. And if I click to the power button, it's the optical port, no power on it. And we don't have light here as well. Usually here it should be flashing white when the TV is about to powering on, and you can see here there is no picture here on the screen. There is no picture, no backlight. So after we removed all the screws, we removed all the screws for the back cover. So don't lift it all the way up, just to here, and just slide it to you. That's how you remove the cover. Okay. So because we have no power at all, the set is completely dead. So we are going to go and check where the power comes from. Is the power board. That's the first check we need to do. Plug the TV to the power. Let's put the multimeter on the alternative volt. So we're going to check here to see if we have 120 coming to the TV. So 120 means the cord is good. This part from here to here is good. We have the rectifier bridge here. Do we have 120 in the rectifier bridge? Yes, we have. So this is the rectifier bridge here. You can see there is a 4 pin. So there is a positive and negative side of the rectifier bridge. That's the output. We check in the input. Right here, we have 120 volt. And this set, it has 2 rectifier bridge. This one, it has 120 volt. So, which means the fuse, various store, capacitors, coils, all these sections here, it's good. And this is the alternative. So now we switch to the DC, or this is the EC. Here, this section is EC. And the output of the rectifier bridge, the voltage is going to be DC. So we switch to the DC mode in the multimeter. We have 160 volt in this rectifier bridge, and this rectifier bridge is 160 volt. So we have 160 volt out. The rectifier bridge is mere rectifier bridge is good, fuse is good, all this part here is good. So let's keep checking. So this side we're going to check every component here. We're going to jump to this big capacitor and we check if we have 160. Yes, we have 160 volt. So we have 160 volt coming all the way to the capacitor, which means the direct circuit, it works. There is 2 circuits here. There is step up and direct circuit. From the rectifier bridge, when the TV in the standby mode, it will be 160 coming to this capacitor. That 160 going to this IC here. This is a power IC for standby voltage, like 5 volt and 3.3 volt. And it's go to this transformer, like switching. This has a MOSFET in it and switching IC. So when the voltages keep cutting off, on off and switch in here. From this transformer, it's gonna go to one of these diodes, and from there it's go to the standby voltage to the main board over there. That's 160 direct voltage. And the second circuit which is here is these two transformer with this switching ICs here. These two transformer is going to make 160 volt that's coming from the rectifier bridge. They're going to double it. They're going to make it 360 up to 390. Then they're going to give it to these big capacitors. This big capacitor, it will be switched in these two MOSFETs here. These two MOSFETs, one of them is going to fit this transformer and is going to fit this area here. That's where is the backlight. The second part is from this transformer. We're going to have the other voltages that the TV need as 12 volt, two kind of the 5 volt. There is a standby and a regular 5 volt. So 5 volt, 12 volt, and even the 24 volt for some audio ICs for the sound. So at the moment, because we have no standby light over there, we're gonna focus on here between this IC, this transformer, the diode, and here to check if we have the standby voltage. So we are not going to check the step up power, because this step up voltage, it works with the power button. When the TV have the standby and you click the power button, you're going to turn on this step up voltage to make the voltage go to the 360. So we have a standby here is a 3.3 volt at the pin number 5. So the pin number 5, so you can see number 1, it's here, which means this one is 1. Next switch is 3. The third one in the bottom is the 5. So in the standby pin, we have 0 volt, no voltage output. We have no standby, of course we are going to have no light. The main board, it's not going to, but we don't know. Could be some surge in the main board causing that 5 volt to go off. There is a chance. So let's disconnect the main board from the power board. We disconnect the backlight. We check if we have the standby voltage here. If not, why we don't have it. So after we disconnect the main board, let's plug the TV again. And we're going to check here, 1, 2, 3. So that's the pin number 5. We still have 0 volt. So that's mean the main board is not the one is causing the 5 volt to go off. Because if there is a short in the main board, of course the 5 volt is not going to be exist. But the main board, it's not what is causing it. We're going to check here. Usually this diode and this capacitor from this transformer is go to this diode filter cap, the output filter capacitor, it's go to here. So the output of this diode, do we have 5 volt here? We don't have 5 volt, it's a 0 volt. We are checking in the cold side. You can see this line. That means this side is the cold side. This side is the hot side, or primary and secondary. So this one is the input voltages, the high voltages. Here the smaller voltages. Even the backlight is called the cold side. Yeah. Sometimes it has like 200 volt in the backlight, but it's still called the cold side. So In the cold side, we can use any metal piece from the TV or the screws here as a ground. In the hot side, we need to use the ground from this big capacitor. We can't use the ground from the... So I'm going to use the ground from this hole, because that's the negative side of the capacitor, as you see. So let me see here if we have these 2 points. Yeah, you can see these 2 points. We have 160. I mean, our ground is good. So let me check in this resistor. Come closer here. We have 160. Output of this resistor 160. I think this resistor is feeding this power IC. So from this power IC, it's going to give like a current voltage. So we have 14 volt here, or 16, 20 volt. This is the start voltage for the IC to start. And we have 31 volt here. That's 31 volt is for the VCC. So let's take the power supply and look at it closely. Okay. So yeah, I'm going to plug the power supply. Then we do some tests to see if we can save this. So the video, it will be a little bit longer for us to learn something from it. So we have to use this one. Get our multimeter. We find out there is a problem in the standby. This circuit here, all the way here to the output. So this circuit here, and I guess this diode here, this capacitor to the output here. Our problem is somewhere here. So by checking in this resistor, we have 160 coming to this IC. So there is 2 volt or 3 voltages, they come to this IC. There is 160 volt from these capacitors. There is the start voltage. There is couple resistors. They come from rectifier bridge to lower the voltage for this IC to start. That's why it's called voltage start. That voltage is go between 12 to 16 volt most of the time. And this should be one of these capacitor and this diode. Then there is the third voltage, is the VCC voltage. That's what the IC use to stay on. Voltage start, it just make the IC start. Make it just to start cutting 160 that's coming from this resistor. They cut it here, the first cut. That first cut, it's go to this transformer. This transformer, it has 2 sides, 2 pins here and 2 pins here. These 2 pins is for to give the voltage to outside. These pins here to give the voltage back to the IC, and that's where is the VCC come from these 2 pins here. Voltage start, make the IC start, it cut 160, that wave, 160 wave come to this coil here. This coil give that voltage to this coil, but is a small. Then this one, it's gonna go to one of these capacitor and diode, one of them here, and that one is gonna filtrate to the IC. When the IC detected the VCC comes back to it, the IC start using the VCC, not the voltage start. So this 3 voltage is very important for the standby circuit. We have 160. Let's see if we have the voltage start. So we use the ground and by these capacitors. So here we have 13 volts, 16 volt, 15, 13. This is where is the voltage start. Most of the time, the voltage start is not stable. That's normal. You see the voltage start sometime like this. We have 31 voltage here, stable. So this 31 voltage stable, that's the VCC. All right. So the IC has there is 160 coming to the IC. There is there is a voltage start. VCC. If we have VCC here, it means the IC is current. Because we have the voltage in this diode, I'm kind of sure the IC work. If this IC doesn't work, we are not going to have the VCC voltage. So we go to the other side of the transformer. The other side of the transformer, we have this diode. Let's use the ground from here. So we have no voltage here. As we did see before, we have no voltage here. So next, let's check if there is any the standby voltage is very simple voltage. We give the power to the IC. The IC have voltage start, has VCC, is going to cut the voltage to the transformer. The transformer is transferred is lower the voltage in the other side. There is diode capacitor, then outside. That's it. Very simple circuit for the standby voltage. So what's make the voltage doesn't go out? There is two things. Could be an open circuit, could be a short. So this is two things. This diode here must be like if it is open or if it is short. Very rare case we might find this transformer open. So let's test the output of the transformer. The coil is good. We have a low ohm because there is just a wire inside it. Let's test short here. In the pen number 5. We have short in the pen number 5. So let's check this diode. There is a short in this diode. Great. There is a short in this diode. Is it a short to the diode itself or some other component? So let's remove the diode. That's the diode. So the diode is here. So let's test it. Do we have a short diode? Hope so. A short diode. A short diode. So what's this diode here is a SB260. SB260. This is a fast diode. Yeah, this is a fast diode, Schottky diode. So we're going to need to find another diode close to this one. We put it and we check. So we check if we still have a short over there. So to the ground, no short, and this side is the ground. Let me go close a little bit. Our transformer is here in this square. You can see these two pins here. So one pin is connected all the way to the positive side of the capacitor. Let's come here. There is a resistor here, and is connected to here. Should be, this is the drain. From the IC, this is the drain, like the MOSFET. So there is a source, is the negative side of the capacitor, this one here. So if we follow it going all the way to here, so that's the ground. And the ground, it should be the same as the source. There is just a resistor between them. Yeah. So this is the drain of the IC. It's go here. These two pins here. That's what is carrying the voltage. This coil here is for the VCC. That's what is powering the switching IC, this one here. And you can see it has a diode here, and it has another diode here. If we follow the diode, it's go here, there is another resistor to here, another diode. It's go here, or from here, there is the trace is going here, and it's going, I think it's going to this pin here. That's the VCC pin. So we're gonna look where is the small capacitor. That's the VCC. So this one or this one is the VCC. But now we need to this side of the our this side of the diode is connected to the ground. It's normal. You can see the capacitor here, positive side, and ground side is here. So this is the ground. This one shouldn't be the ground. So let me replace this diode, and we see if we still have, if we can get the standby voltage. So usually the companies, they put this kind of the diode is a double diode, two diodes, not just one. Plus it has the heat sink with the diode. When the diode getting hot, because the diode there is a alternative power coming to it, so it goes 0 to 12 volt or 5 volt, up down. For the diode to smooth it, it's going to transfer that power to the heat. So the company, they put this heat sink to keep the diode in the stable temperature. But the SONY put this small diode in a $3,000 TV. So I'm going to use this bigger diode. So it's going to handle more heat and more power. And where to get the diode? There is two kinds of the diode in the boards. There is this diode, that's in the hot side, where is the high voltage, where is the input voltage. And there is this diodes here in the cold side by the capacitors. We need these diodes that they are on the cold side. and this is SF. So S is for Schottky diode. Yeah, Sony used these little tubes here to hold the diode in the place. So Sony was worried about the cold solder joint to get cracked, but doesn't worry that diode is not strong enough to handle the heat or to handle any change in the voltage. So I'm gonna need to remove this one. Okay. And now we can put our diode, and we respect the symbol of the direction of the diode. We can't put it in a wrong way. We're gonna burn the main board. Okay, we solder the diode in the right place, and we be sure we make no solder breach anywhere when we are soldering. And now the moment of the truth. Let's see if, okay, in case if that diode is explode. Is not an explode, that's good. So let's test the voltage. This one in the ground, 3.4 volt. That is fixed. We see it better now, I think. 3.4 volt in the output of the diode. And here, this standby is not a 5 volt. This standby is a 3.3 volt. It's over there. So let's check all the way in the output, the pin. 5 volt pin is here, right here, 3.4 volt. That's great. So we have standby voltage. Let's go to the TV. Good. All right, so everything is connected. Let's connect the power. I hear the relay click. I did see the backlight is over there. We have any picture? Yeah, we have something.
Oh yeah,
it's over there.
The logo.
Yeah. And we have, that's a Google sign. It's over there. TV works. So TV works. And another big TV saved. So this is all for this video. Thank you for watching, and we'll see you again.